Hello everyone, I'm Sarish Mitra from Sri Venkateshwara College of Engineering. I'm a second year student pursuing BE in Computer Science and Engineering. Today, I'll be giving a presentation on the topic sorting techniques. So, introduction to sorting techniques. Sorting is a fundamental operation in computer science where data elements are arranged in a specific order. This is introductory section will provide an overview of various sorting techniques focusing on brute approach. Sorting is an essential for data efficient management and retrieval. Understanding these techniques is crucial for algorithm design and optimization. What is brute force approach? The brute force approach, also known as exhaustive search method, is a fundamental problem-solving technique in computer science. It involves systematic enumerate all possible candidates for the solution and checking if each candidate satisfies the statement of the problem. The method is often used when a problem is small and the solution can be found within a reasonable time. Brute force approach is characterized by its simplicity and straightforward implementation, as it does not require any sophisticated algorithms or special techniques. However, it is a time complexity often grows exponentially with the size of the problem, making it impractical for large scale problems. Despite its limitation, the brute force approach is still widely used in various applications, especially when the problem size is manageable and the solution is not too complex. Bubble sort. First, compare. Compare adjacent elements. Second, swap. Swap if they are wrong in the wrong order. Third, repeat. Repeat until the list is sorted. Bubble sort is a simple sorting algorithm that repeats steps throughout the list, compare adjacent element, and swaps them if they're in wrong order. The process is repeated until the entire list is sorted in ascending order. While easy to understand and implement, bubble sort is not the most efficient sorting algorithm, especially for large dataset. However, it can be useful for techniques within smaller datasets or as an educational example of brute force sorting method. Next is selection sort. First, compare. If the elements are compared to the smallest one, swap. Swap the smallest unsorted element first. Repeat the process. Selection sort is a simple brute force sorting algorithm that works repeatedly by finding the minimum element from the unsorted part of the array and swapping it with the first element of the unsorted part. The algorithm continues this process until entire array is sorted. Although simple selection sort has a time complexity of O n to the power, making it inefficient for large dataset. Insertion sort. Insertion sort. Sorting one element at a time. Insertion sort is the simple sorting algorithm that works by iterating through an array, taking one element at a time and inserting it into a correct position in the sorted portion of the array. This part is done by comparing the current elements to the elements sorted in the array. Efficient for small dataset. Insertion sort is particularly efficient for small data set as it has time complexity of O n to the power square in the average and worst cases. It is also relative simply to implement and can be a good choice for sorting small arrays or partial sorted data. Step by step process. The insertion sort algorithm works by taking the first element of the unsorted portion of array and comparing it with the element in the sorted portion. If the current element is in the smaller and the larger portion where it is being compared, it is inserted correctly in the position, shifting all larger elements to the right. Time complexity of brute force sorting. The time complexity of brute force sorting algorithms such as bubble sort, selection sort, and insertion sort is typically O n to the power 2, where n represents the size of an input array. That means that the size of the input grows, the time required to sort data increases exponentially. The O n to the power 2 complexity of these algorithms stems from the fact that they rely on nested loops to compare and swap elements, resulting in quadratic growth in the number of operations performed. This makes them inefficient for large dataset where sophisticated sorting algorithms such as merge sort, quick sort are typically preferred for better time complexity. Advantages of brute force sorting. Simplicity. Brute force sorting algorithms such as bubble sort, selection sort, and insertion sort are relatively simple to understand and implement. They use straightforward logic and do not require complex data structures or advanced mathematical concepts. Easy implementation. Due to the simplicity, brute force sorting algorithms can be easily implemented, making them a good choice for small data set or educational purpose. They can be useful for quickly sorting data without the need for complex optimization. Robustness. The brute force sorting algorithms are generally robust and can handle a wide range of input data, including arrays duplicate elements of partially sorted data. They do not make any assumptions about the input data, making them versatile and reliable. Stability. Some brute force sorting techniques like insert sort are stable, meaning that they preserve relative order of equal elements in the input. This can be important in certain applications where order of data needs to be maintained. Disadvantages of brute force sorting: slow performance. Brute force algorithms such as bubble sort, selection sort, or insertion sort have a time complexity of O(n) to the power 2, which means they become increasingly slow as the input size grows, making this makes them impractical for sorting large data set where efficient algorithms are required to ensure acceptable performance. High memory usage. Brute force sorting algorithms typically require additional memory to store temporary variables or swap variables, leading to higher memory usage compared to space efficient storing algorithms. This can concern in environment limited memory resources such as embedded systems or mobile devices. Lack of optimization. Brute force sorting algorithms do not employ any advancement optimization techniques such as divide and conquer or comparison based optimization. As the result, they may not have advantage of certain properties of the input, leading to suboptimal performance in specific scenario. Applications of brute force sorting. Simple implementation. Brute force sorting like bubble sort, selection sort, insertion sort are easy to implement and understand. They are often used in introductory computer science courses to teach the fundamental of sorting. Small dataset. Brute force sorting methods work for small datasets where the time complexity is not a major concern. They can provide a satisfactory performance for sorting a limited number of elements. Educational purpose. These simple sorting techniques are valuable in educational tools. They help students grasp the basic concept of sorting and algorithm analysis. Comparing the performance of brute force methods, efficient algorithm is an insightful learning experience. Comparison to other sorting algorithms, brute force techniques such as bubble sort, selection sort, and insertion sort are often constructed with more efficient algorithms like quicksort, mergesort, and heapsort. While brute force approach are simple to understand and implement, they have higher time complexity, making them less suitable for large dataset. In comparison, advanced sorting algorithms leverage specialized strategy to achieve better performance with O and log n time complexity. A key advantage of brute force is ease implementation, making it a popular choice for introductory programming course and small scale applications. However, as the data size performance limitations of these approaches are becomes more apparent, the drive for needing more sophisticated sorting techniques can handle large and more complex data efficiently. So we have a list here with time complexity and space complexity. Bubble sort is stable, selection sort is not stable, sort is stable, quick sort is not stable, merge sort is stable, and heap sort is not stable. Thank you for viewing this video. Please do like, share, and subscribe to this video. Have a great day.